Hello everyone, hopefully you can all hear me. Welcome to this webinar presentation on how to get faster SQL servers using our Vlocity IO reduction software. My name is Spencer Allingham. I'm the Technical Director for Condusiv Technologies for Europe, Middle East and Africa. Let's go through to the first slide and we'll get started. So, some of you may not have heard of Condusiv in the past. You might know of one of our older products called Diskkeeper. You might remember it as being a disk defragmenter from years and years ago. It was a fantastic disk defragmenter, but as technology has moved on, so has our software technology. What we're doing today is really not about defragmentation at all. It's much more about optimizing performance and reducing I/O traffic that has to be dealt with by the back-end storage in your systems that are underpinning these SQL servers and other systems that you would have in your environment as well. Things like file servers, SharePoint servers, maybe you've got some application servers or business information systems like IBM Cognos or maybe SAP or Microsoft Dynamics. All of these things will be generating storage I/O traffic. And the reason why I/O reduction to the storage is important is that that storage that's underpinning all of these servers is really the slowest part of your IT infrastructure, your IT stack. If you compare the speed at which operations can happen down at the storage layer to the speed at which things happen at a processor layer or in server-side DRAM, that storage is always going to be the slowest part of the infrastructure. Even if you have an all-flash array or if you've got a tray of SSDs sitting in the first tier of your SAN storage, for example, it's still going to be the slowest part of the infrastructure. So when you're running things like SQL Server over that back-end storage, it makes absolute sense to make sure that that storage is running as efficiently as it possibly can and to try and lighten its workload as much as possible. So that's a little bit about what we're going to be talking about today. I mean, as a company, we have been around for well over 30 years. I think somebody told me recently we're something like the 16th oldest software company that's still in existence, which is very, very cool. Some of the technology that I'm going to talk about that we use to optimize SQL servers has been licensed to quite a lot of the top hardware manufacturers in the world. So people like Samsung, HP, Dell, and so on. They use this technology to make their products run faster and stay running fast. And something that I'm very proud of, just recently we actually got certification from Microsoft for running our software with SQL 2016. And they did some tests in the Azure cloud, of course running SQL 2016. And they created they used a load generator called HammerDB to generate a sort of online transaction processing type workload. So I think an e-commerce environment where you've got lots of users ordering stuff, whatever it may be, with SQL underpinning it at the back end. Now, not only were we able to jump through all of the hoops in order for Microsoft to give us the certification, which was very, very cool, we actually showed that we were able to get 28% more SQL transactions done in the same amount of time, and that directly equated into 28% more orders that could be processed by that SQL instance, which was very, very nice. And I think that that is kind of a conservative percentage because they were quite RAM restricted. And the reason why that's important will become apparent shortly. But if they were to give it a little bit more memory, I think we would have been able to provide more SQL transactions than 28%. But 28% more workload out of a SQL instance is a very good starting point, I think. Hopefully you'll agree. So let's flip on to the next slide. This is going back to a survey that we conducted with, I think it was several thousand IT professionals at the beginning of this year. And we asked a whole number of questions, but this particular one is relevant for you chaps that are running SQL Server. So the question was, regarding your I/O intensive applications running on SQL, do you experience staff or customer complaints due to sluggish performance? Now, thankfully, most of the respondents said no, everything's running fine, we don't get user complaints. But I wonder if this rings true with you. 27% of the respondents said, actually, yes, we do get complaints. And I suspect that a good number of these people that said no would probably still benefit from being able to get more performance out of their SQL servers. So let's have a chat about what it is. One of the things that really chews through the performance of things like SQL servers. Of course, there are many different things. I mean, often I come across people who say to me, oh, well, we've got some SQL queries that are badly written, for example, or the database isn't structured in perhaps the best way it could be. We aren't going to be able to help you with those, but what we are going to be able to help you with is the storage I/O traffic that SQL generates, so that we can reduce and optimize that traffic. Oh, and by the way, just a brief housekeeping note while I think of it. If you guys have any questions about any of this stuff as we're going through, please do feel free to put it into the Q&A box. It should be on the bottom right-hand side of the WebEx window here. And at the end, I'll try and answer all of the questions that you have. I'll certainly do my best to anyway. But yeah, feel free to use that Q&A box and throw any questions that you have. So why is storage traffic inefficient? Well, as an example, we've got a rough representation of a virtualized environment here. We've got a hypervisor sitting in the middle, so this might be a VMware ESXi box or a Microsoft Hyper-V server, and they're hosting a number of virtual machines, and they're sitting above a back-end storage, which is typically a SAN, but doesn't have to be. It could be other types of storage as well. So let's say inside these virtual machines, you're running your instances of SQL Server. They're all generating storage I/O traffic, which is being funneled down through that physical host hypervisor machine and then on down to the storage at the back end. Now, this is what it looks like when everything's working well, everything's being efficient. And by that, what I mean is you have the least number of storage I/O packets, each one carrying the most amount of data, so that when it arrives down here at the storage controller, it's arriving in nice large chunks at a time. And that gives the storage controller the opportunity to create nice large unbroken stripes across its media using the least number of storage level transactions. So that's very efficient. And typically that's why it's best practice when you're formatting NTFS volumes to be used by SQL Server, that you would give it a nice large cluster size, like a 64 kilobyte cluster size, so that it helps to mitigate a lot of these split IOs, which is what's on the next screen. So this is what it looks like when everything's working well. But when you're running Windows in these virtual machines, this is typically not what you're actually going to get. What you're actually going to get is going to look more like this. So what's happening here? Now you've got SQL running in these virtual machines, still generating storage I/O traffic, but the packet sizes now are so much smaller. So what's causing that is the free space in these NTFS volumes. As you create new files, you delete files, you extend files, and you move files around on these NTFS volumes, what will naturally happen to the free space is that it will become more and more split up into smaller and smaller free space extents. So now what's happening is the Windows write driver is being given a right to perform. It goes to the Windows free space cache and says, hey, free space cache, where's my first available bit of free space? I've got this write to do. It then gets given that address, it starts writing out its data, and then it'll find, I don't actually have enough room to complete this write. So I'm going to split the I/O. I'll send the data I've already written on down to the storage, go back to the Windows free space cache, find my next available free space extent, and I'll continue writing there. And it'll find again, Still don't have enough room in this new free space extent. So I'm going to split the I/O again, go back to the Windows free space cache again to get my next free space extent, and I'll continue writing there. And basically repeat and repeat and repeat until it's been able to complete the right operation. Now, in the real world, what this means is that an average gigabyte of storage I/O traffic that should take somewhere between 2,000 and 3,000 I/Os to complete is now taking 30,000 or 40,000 I/Os to complete. It's now a much less efficient way of moving that data between server and storage. And it's also inefficient if that data needs to be read back in afterwards. What it means is the data's arriving down here now at the storage controller only in very small chunks at a time. There's no way the storage controller can understand the relationship between these storage I/O packets because it's too far abstracted away from the level at the top where the storage I/O traffic generated. So now it's only got the opportunity to create very small stripes across its media, and that means a lot more storage level operations are required to process that same amount of data. It's a bit like saying, on this side of the room, I have a liter of water, which is my data, and I need to move it to this side of the room, which is where the storage is. It's basically a lot more efficient to make one trip with a liter-sized jug than it is to take that same amount of water and pour it into lots of tiny shot glasses, and then take the first shot glass across the room, and then come back and take the next shot glass across the room, and then come back and take the next shot glass across the room. You see how these small shot glass-sized I/Os make the whole infrastructure work so much harder than it actually needs to process any given gigabyte of storage I/O traffic. So what do we do to mitigate this and make things more efficient? It's certainly something that you should be thinking about, especially if running things like SQL that do generate a lot of storage I/O traffic. So what we do is we install our very lightweight software into the Windows operating system, just as the same as you would install any other piece of software. It's just a few clicks to get it installed. And what it does is it adds an extra layer of intelligence to the Windows write driver, so that instead of having to go back to that Windows free space cache, it says, hey, write driver, start writing here on the NTFS volume, where there is a large enough area of free space to put that data into without having to split it up, or split it up the least. And of course, another part of the software is it will quietly, automatically, in the background, using otherwise idle resources, to create these nice large areas of free space to make it easier to write into as well. So what that does, the effect that has, is that it significantly reduces the number of I/O packets that need to go out to the storage. What you're doing is replacing this bad I/O traffic, this laggy, excess, unnecessary I/O traffic, with much fewer, larger I/Os that are a lot more efficient to move between server and storage and back again if that data needs to be read. So now the data's arriving down here at the storage controller again in these nice large chunks. The storage controller has the opportunity to create nice, large, unbroken stripes across its media using much fewer storage level operations before it can acknowledge that write and send that acknowledgement back up to the operating system that started the request. So, as I say, that significantly reduces the number of excess unnecessary I/O packets, but that's only part of the story. What we also do is use a RAM caching technique so that we can use some of the idle available memory that's sitting here in these Windows machines. And from that RAM cache that we set up there, we can satisfy a good percentage of the read I/O traffic so that it doesn't have to hit this part of the estate at all. If we can satisfy 20, 30, 40% of all of the read I/O traffic from server-side DRAM, that means two things. Firstly, that traffic that we can satisfy from the RAM cache is satisfied at the speed of RAM. rather than the speed of the media in the back-end storage. And to give you an idea, RAM is roughly 10 times faster than solid-state drives, you know, and an all-flash array. It's still, RAM is going to be faster. But what it also represents is a further reduction in the amount of I/O traffic that has to be dealt with by this part of the estate. So now we've significantly reduced the writes and displaced them with larger write packets that are much more efficient, and then we've further reduced the I/O traffic by taking a percentage of those reads and having them satisfied by server-side DRAM. So let's flip on to the next slide here, if I can hit the right, there we go. So this is kind of going over what I've just mentioned. So we've got these large, clean, contiguous or unbroken writes for more data payload with every operation. We're caching those hot reads from idle available RAM. We have a benefits dashboard that I'll show you in just a second that not only shows you just how much I/O traffic has been eliminated from having to go out to that slower back-end storage, but what percentage of read I/Os didn't have to go out and what percentage of write I/Os didn't have to go out. And it will show you how much storage I/O time that has saved. And the last point on here I'm also quite proud of. There's not many software companies that would provide you with this type of guarantee, but we do guarantee to solve the toughest storage performance issues that you're having with SQL or other servers that you're running in your environment, or quite frankly, we'll give you your money back. As I say, there's not many software companies that would offer that type of guarantee, but hopefully it's an indication of just how confident we are that this stuff works. You know, we've been creating caching technologies, for example, since I think the early 80s. So we're quite expert at it now. So let's talk a little bit more about this write I/O reduction. Something that's dear to the heart of many SQL DB admins is ACID compliancy. You want to make sure that you stay ACID compliant, and of course we do. When we're giving that extra layer of intelligence to the write driver, we're not bypassing Windows in any way. It is the standard Windows write driver creating a standard NTFS storage I/O packet and sending it out to the storage. We're not doing anything clever like trying to deduplicate or compress, or we're not touching the data in the I/O packet at all. We're simply allowing Windows to make better choices when it's writing that data, so that everything below that point in the storage stack benefits by receiving less work to do, and the work it does receive is already optimized into these larger I/O packets. And so RAM caching, we spoke about that a moment ago. We will never compete for resources, including RAM, with anything else that's running in the machine. In every Windows machine, there should be an amount of idle available memory sitting there, not being used by anything. If there isn't, then you'll be having huge performance problems by swapping to the page file, for example. And that's going to cause a massive overhead by itself. And I'm sure these days, nobody's restricted their memory that much. But where there is some idle available memory sitting there, we can use that to, or some of that, to create a RAM cache that is dynamically sized. So it can grow and shrink depending on the resource requirements of everything else that you're running in the machine. So if you were to spin up a new process that needs a new working set of pages of memory, we would shrink our cache ahead of time, hand pages of memory back to non-paged pool to make sure we never compete for RAM with this, even this new process that's just started up. We will shrink our cache to a 0 size if need be, and still leave 1.5 gig of free memory available on the system, just to make sure that we're never the cause of it running out or starving from a memory point of view. Often people ask me, well, how much memory should we leave free for Vlocity to work with? As a general rule of thumb, I would suggest if you can leave at least 4 gigabytes of available physical memory, unused memory, that's usually enough to provide us with roughly a 2 gigabyte cache size, and that's usually enough to eliminate somewhere between 30 and 50% of all of that read traffic from having to go out and hit the back-end storage. The algorithms that we have to work out what needs to be in the RAM cache are very, very smart. There's about 16 different algorithms, I believe, and I won't bore you by going through every single one of them, but one of the main ones uses a telemetry technique. So it learns over time what the main applications are that are running in the machine, what type of files are being accessed, what type of I/O streams are being generated, and at what times of the day, the week, the month, the quarter, so that it can become really intelligent about what blocks of data are hot and need to be in the cache and when. And it also focuses very much on the type of storage I/O traffic that tends to chew through the performance of the storage the most, which tends to be the smaller, more random read I/O traffic. Now, often when I'm talking with people about our technology in SQL, they say, well, SQL's got its own form of caching called buffering, and they're right. And I'm not suggesting you turn that off at all. The benefits that we can provide with our technology are in addition to the caching that you will get from SQL, and in addition to the caching that's built into the Windows operating system at all. Don't turn any of those off. Keep them on, but we can provide you additional benefit and performance gains by running our software. Now, SQL, as most of you will know, is not so much memory hungry as it is memory addicted. If you don't cap the amount of memory that SQL can take for itself, it'll chew through almost all of the available memory on a system and typically only leave a few hundred megabytes free. And what it's trying to do is basically cram as much of its database or databases into that RAM as it can, but it doesn't always do a very good job of working out what data actually should be held in that RAM cache. So are you robbing Peter to pay Paul if you're capping the amount that SQL can take for itself and providing some for the Vlocity? No, you're not, because Vlocity can make much better use of that RAM cache space because of the algorithms that it's got to figure out what's hot and what's not. It also uses a very lightweight compression algorithm to be able to fit more blocks of data into the same amount of RAM cache space as well. The net result is SQL, especially if it's more read heavy, is going to run faster. You're going to be able to get faster SQL transactions, more SQL transactions done per minute, per hour, per day, depending on how busy your SQL servers are. Another thing that's worth keeping in mind as well, I mentioned this earlier, you may well have other non-SQL machines that are sharing the same storage, especially if you've got a SAN or storage area network on the back end. These other systems can be chewing through the performance of that back-end storage as well and adversely affecting your instances of SQL. Let's say, for example, you've got some SQL over here and you've got some file servers, maybe a busy FTP server, maybe you've got SharePoint running or an application that interfaces with that SQL, and they're all generating a lot of storage I/O traffic all down to that shared SAN. My recommendation would be put the software onto all of those machines that are sharing that same SAN. The reason being, now you are eliminating the most workload that you can from that slower back-end storage. And now everything sitting above it will benefit, rather than just putting it onto the SQL servers when you could still have those file servers, for example, still chewing through the performance of the storage and creating an I/O queue. Hopefully that makes sense. So this is what some of our customers typically look like. These are all case studies that are available to download and read from our website if you want any light bedtime reading. I won't bore you by going through every single one of these, but I'll pick out a few that I think might be relevant. This company down here on the left, the bottom left, Bell Mobility, they're a telecoms company in Canada. We reduced the I/O traffic going out to their storage by 61%, and that gave them SQL report queries that were 3 times faster. No additional hardware required. We took their existing environment that they've already paid for, they've already bought, and we made it operate as efficiently as it possibly can. And that's how we got these SQL queries that were 3 times faster. ASL Marketing here in the middle, they were doing SQL batch imports that were taking 27 hours to complete, and that's a pretty long time. We were able to drop that to just 12 hours. So from 27 hours down to 12 hours, and all they did was install a simple piece of software. There was no additional hardware required. We didn't throw in a tray of SSDs or put a PCIe flash card in. It's just a simple software utility to achieve that. And the last one I'll pick out is this one up here, Creative Office Pavilion. Response times for SQL, their CRM and email are now significantly faster. Now they're actually getting all of the compute they've paid for, rather than wasting a good percentage of it to this slow, excess, unnecessary, laggy storage traffic that frankly doesn't need to happen. More customer examples. Again, I won't give you death by PowerPoint by reading every single one of these out, but this is an interesting one. Alvar University. They had 3,000 students accessing a learning management system application, and it was timing out because of the poor storage performance. The traditional solution would have been to rip and replace their SAN with something a lot more expensive, like an all-flash array, but simply they didn't have the budget to do that. So they put the Vlocity software in there, and we were able to double the performance of their SQL database, and all of the timeouts that they were seeing under peak load went away. They disappeared. So that was a really good story, a really good case study. Admiral Metals, just underneath, their users would experience lag under peak load on their in-house written application when querying metal prices, which were stored in a SQL server at the back end. Again, we doubled the SQL performance there, and all lag disappeared. And the last one I'll pick out here is this one, Agrium. Their SQL databases began to slow down over time, and they were only 3 years into their storage lifespan. They were expecting to get 5 years out of this storage, but already 3 years in, it was starting to slow down. We, again, doubled the performance on their existing hardware infrastructure, and not only is that allowing them to keep their SAN storage for the full 5 years, they're now looking at keeping it running for longer and sweating that expensive storage asset for a greater period of time, which is fantastic. So here's an example of part of the dashboard reporting that's in our software. You can see over here the total number of I/O packets that were eliminated from having to go out to the back-end storage in this case, the last 2 weeks. So it's eliminated over 12 million I/Os from the underlying storage. 50% of all of the read I/O traffic didn't have to go out to the storage. And about 30% of all of the writes didn't have to go out to the storage. And what that meant was that they saved over 5.5 hours of storage I/O time. Now, with an operating system like Windows, this is not linear time that you would measure with a watch or a clock, because a lot of that I/O traffic can be generated in parallel. What this figure represents is the number of I/Os that were eliminated from having to go out to the storage, multiplied by the average I/O response time at the time those I/Os were being generated. So I hope that makes sense. If I haven't made that clear, put a question in the box on the bottom right, and I'll try and address that in more detail at the end. Hopefully it makes sense though. And this is typically what you would expect to see. If I mentioned before, if you can leave at least 4 gigabytes of available physical memory, that's usually enough to eliminate somewhere between 30 to 50% of all of those reads and about 30% of all of those writes. So next steps options. I mentioned we have the 90-day money-back guarantee, but of course people are going to want to try the software first. Now, everybody that's registered and attended today will receive a single full copy of the software, and that's yours to keep. It's not trialware. It'll run fully featured for as long as you want to run it for. And I would suggest that to see that the software works as advertised. Put it onto one of your worst performing servers, or try it in a dev environment first and put it through its paces, and just see how much storage traffic can be eliminated from that back-end server. That's a great way of getting to know the software and seeing how easy it is to install, well, there is no configuration really. You basically just install it and leave it to do its thing, and just check that dashboard to make sure that you're getting IO traffic being eliminated. It really is that easy. It'll take you somewhere between 1 and 2 minutes to install and set up. You will have to reboot the server before the software can become active, but you're not forced to reboot immediately after the install. So you could install now and reboot during a maintenance window at the weekend, or whenever your next patch Tuesday is, for example. But the best way of really doing a proper proof of concept, where you're really going to get the most bang for buck, is to use this 30-day evaluation version of the software, which again, we're very happy to provide you with. It'll run fully featured for 30 days, and then you can put it onto as many machines as you possibly can that are sharing the same storage. That way you will get the most storage IO traffic elimination. You're reducing the workload on that back-end storage the most, regardless of which machine and which applications are generating that traffic at any time. And that really is going to give you the best performance gains on all of those applications that are sitting above. Again, quite often I will run proof of concepts with customers and pre-customers, if I'm allowed to call them that, who are looking at the software. And yeah, we'll run the software for maybe 2 weeks. Then we'll gather some of those dashboard reports, and I can put together an engineer's report and step through the results with you to really show you just what it's been able to do. And then we can ideally tie in some of the metrics that you care about as well. So things like how many SQL transactions were done per hour or per day, or what was the average speed of SQL transactions, or something like these payroll reports that were taking an hour and a half to run. Now, are they taking significantly less? Are they now only taking 20 or 30 minutes to complete? Or maybe you've got some back-end batch jobs that are taking too long. Maybe we can shorten the elapsed time for those as well. So what I'm trying to say is, use and abuse us. We're here to help you. We can provide you with the software. We can help you get it installed if you want us to. We can help you interpret the results. Now, there's one final thing that I wanted to mention, and then I'll get on to the Q&A stuff. We also have another free utility called the IO assessment tool. And sometimes in larger organizations, this is a more sensible way to start. Because in large corporate organizations, usually you would have to go through a change control procedure before you bring new software in and start running it, even to evaluate it. You're not going to be able to put it onto just live systems and have it do its thing. The IO assessment tool is very useful in this instance because it is completely non-disruptive. You don't install anything on any live servers. You don't have to reboot anything. You simply install it on a machine that can see those live servers on the network. It then uses Windows Management Instrumentation, or WMI, which is a part of the Windows operating system already. It's already sitting there in your instances of Windows. And it grabs some of the counters and metrics, again, that are sitting there in every Windows installation. Normally, they get used by things like Windows Performance Monitor or Resource Monitor or the Task Manager. And we'll put that data into a simple text CSV file and then analyze at the end to produce a very easy to read report that actually color codes the machines that have been measured red, yellow, or green, depending on whether they're being critically impacted by storage performance inefficiencies like split IOs, large IO queue depths, large storage latency that sort of thing. Orange if they're being moderately impacted, and green if actually they're running just fine. And then it'll list out all of the metrics that we've measured and show you what time of the day is worse than others. And at the end, there's a little conclusion section that says, Mr. Customer, your potential for performance optimization with a product like Vlocity is either high, medium, or low, depending on what we found. And then we'll explain that conclusion with a few bullet points at the end. So often, that's a really great way to answer questions like, do I have storage performance inefficiencies that are affecting SQL servers and others that are sitting over this storage? And if I do have inefficiencies, what are they? What machines are they occurring on, and at what time of the day? So again, we can step through that information with you, provide you with an engineer's report, which you can then use as justification to get a change control approved to then run the full trialware and just see what difference it can make to things like SQL. Okay, so thank you very much for listening to me waffle on like that. I hope that's all okay and made some sense. I'm just going to have a look through and see what questions we've got. Oh, good. We do have some questions here. Let's have a look through. So, Adrian Marius says, "Hi Spencer, what can Vlocity do for improving Microsoft Navision 2015 performance?" Now, I have to apologize. I'm not particularly familiar with Navision, so I don't know what the profile is like for storage I/O traffic. What I can say is if the traffic is high, whether it's reads, writes, or a combination of the both, it's only going to help improve the performance. But I can't be more specific than that because I don't know that product particularly myself, so I apologize for that. Jonathan Jackman says, does this work on physical SQL servers as well, or just virtual servers? Great question. It works, I was going to say equally well on physical SQL servers, but actually in my experience, it often works even better on physical SQL servers. Quite simply because when you're provisioning virtual machines, you are thinking, okay, how many VMs can I fit onto this hypervisor? And that will cause you to tend to be a little bit more strict on how much memory is assigned to each virtual machine. But where you have a mid-sized or large SQL physical server, there will more likely be a larger amount of memory sitting in that machine. And often not being used for anything. So we can then have a larger cache size and then reduce that read IO traffic even more, just simply because we have a larger cache size to play with. So I hope that answers that one. So Steve Strong says, is a server reboot required for the software installation? It is. I'm afraid there's no way of getting around that at the moment. We are going to be bringing out a version next year that is, we're calling it internally the no reboot version, where you would install it once, reboot, and then any further upgrades that come down the line, you won't have to reboot the machines again. But if you're not running the software, you're going to have to reboot at least once to get the software installed the first time. You're not forced to reboot immediately after the installation. I think I mentioned that before. So you could install that this afternoon or tomorrow and then reboot during the evening or wait until the weekend or wait until the next time the machine's rebooted with something else. So, okay, so Adrian says, what are the risks testing Vlocity on Navision 2015 production environment multi-user? So again, forgive me, I'm not particularly familiar with Navision myself, but in terms of risks running it, the software is very, very robust. To give you an idea, we've had deep engineering relationships with Microsoft since the mid-90s when they brought out Windows NT 4. Hopefully most of you are far too young to remember that. I'm not, unfortunately. Yeah, we've been working with Microsoft as a gold partner ever since that time. there is an API that's built into Windows. It's still there even today, called the Move File API. Our engineers, we co-developed that with Microsoft engineers, and it controls the movement of data in clusters around on an NTFS volume. That gives you an idea of just how deep our engineering levels go with Microsoft. What's also worth mentioning is that every version of the software is certified by Microsoft before it gets released to the public. So we go, for example, to something called Microsoft Plugfest, which is, to my mind, quite unfortunately named, but that's what it's called, and I can't do anything about that. What this basically is all of the vendors like us getting together at Microsoft in the US, all of our top engineers get together, and in their development environments and test environments, we put all of our software together and we test it to make sure that all of our storage filter drivers play nicely with each other. So we're there, people like Semantic are there, and Kaspersky and others I'm sure would be there. And as a result of this testing, making sure that we all play nicely with each other, we get certification from Microsoft, and Microsoft themselves sign our storage filter drivers. So this software is being used in thousands and thousands and thousands of sites of all different types and configurations all over the world. The software is very, very robust. Hell, if it wasn't, we wouldn't be here still after 30 years. So hopefully that gives you some idea. But at the end of the day, don't take my word for it. Try it for yourself. If you want to copy and try it in a test environment, I'll happily provide it to you. Just reach out to me personally, and I'll get a download link to you. My email address is sreemia@condusiv.com, and that's a bit of a mouthful to remember, so I'm going to put it in the chat box here as well for you. There we go. So, I've just put it into the wrong box. Well done, Spencer. Here we go. sreemia@condusiv.com. There we go. So, if you want a copy to put in a test environment and have a play with, just reach out to me. I'll be very happy to provide that to you. So let's get back to the questions here. So Andrew says, we have mounted NFS volumes through our ESXi hosts, and all Windows OS VMs are located on these. We have RDMs for our SQL database files, logs, etc. for NetApp Snap Manager for SQL backup purposes. Will your software help? Now, I believe it will, because the layer that we're operating at is right effectively at the top of the storage stack. So what you're doing underneath down at the virtualization layer is kind of abstracted away from the level that we are. What we're dealing with is the Windows write driver interfacing with the NTFS volumes. So we're sitting above that layer and doing everything that we need to do there, so that basically what comes out and starts hitting the rest of the storage stack is less workload that is pre-optimized into these larger chunks at a time. So with this type of configuration, it will be absolutely fine. As long as those NTFS volumes are mounted in Windows, it's going to work. If you had, for example, a network share on another server somewhere, and maybe you've mapped a drive letter to it, it won't work with that. It won't work with network shares like that. But the volumes, if they're mounted in Windows, it absolutely will work. So I hope that answers that one. Let's see here. Martin Eberl, oh, forgive me if I've not pronounced that right. Martin Eberl or Eberly. How does this work when the RAM cache doesn't know if it still has the correct data in the case of SQL Server? Okay, so any writes that occur will go straight out to the storage. Okay, No questions, no ifs, no buts. We're only satisfying read IO requests from the RAM cache. We also are very quick to flush that cache if need be. So you're not going to start seeing stale data in the cache. It just simply doesn't happen. Yeah, again, try it and you'll see it for yourself. Steve says, should SQL memory be limited so there is enough RAM for the cache? I would suggest that is kind of best practice these days anyway. Yes, if you're going to put Vlocity in, cap the amount that SQL can take for itself so that you leave at least 4 gig of available physical memory so that we've got enough memory to cache with and to use. Capping SQL, as you probably know, is really quite straightforward. And if you don't know how to do it, there's a great write-up on it on Pete Bursky's website. If you Google that, you'll find it fairly easily. Bursky is B-U-R-S-K-Y. But if you just do a Google search for how to cap the amount of RAM that SQL takes, you'll find it. It'll be in the first 1 or 2 results. So yes, I would make sure, if you're not doing it already, that you cap the amount that SQL can take for itself. Otherwise, we won't have enough memory to play with to create a cache and cache with properly. And then you're only effectively using half of our software. You're only allowing the bit to work that can reduce the amount of write IO packets when you're writing. You wouldn't be getting that benefit from the RAM caching as well. So Martin says, is there anything which could worsen performance when using the software? Actually, no, there really isn't. The only possible outcomes, there's 2 possible outcomes of putting the software in. Either the environment will run as it was before, or you're going to get a positive improvement. So why would it only run as it was before and not give you a positive improvement? Well, going back to the last question, maybe there's not enough RAM to cache with properly, and it is a particularly read-heavy workload. Or maybe the workload on a particular server is so light and there isn't much storage IO traffic being generated. Well, there isn't really a lot for our software to do. So think DNS server or DHCP server. That's not going to be generating a lot of storage IO traffic, so then there's not a lot for us to optimize. But that isn't generally the case on things like busy SQL servers. Right, so Martin again says, guess the performance benefit is different from case to case. What is the origin for this difference? Meaning, in which scenario does the software not make any sense? Well, I've kind of just covered that. The general sweet spots for this type of technology are servers which are generating a good amount of storage IO traffic, where the servers are busy interfacing with the storage. That's where we can help the most. If you've got a server that's really not doing much in terms of storage traffic, well, we're not going to set the world alight there. It's not a panacea for all situations, but really those busy servers, those are the ones you want to target with this type of technology. Andrew Williams says, will there be some tangible benefit without installing across the entire estate? Yes, there will. Absolutely. Let's say you have, for example, 100 machines all sharing the same SAN. 10 of those machines are your SQL servers. So you put the software onto those 10 machines. It will reduce the number of IO packets flowing out from those 10 machines to the storage. It will help to reduce IO queue depths and help to reduce average storage latency by using some of that idle available memory. And you'll be able to measure those differences on those machines. But remember, you still have 90 other machines sharing that same storage that are still potentially generating this excess unnecessary storage IO traffic, and that could still be chewing through the performance on the storage at the back end. So yes, you can measure the improvements made on those 10 SQL servers, but you might still have other machines killing the performance in the storage. So if you were to put the software onto all 100 machines, now from the point of view of the storage, it's doing the least amount of work. It's I/O queue, if it has one, is now significantly decreased. What we've effectively done is taken as much of that I/O traffic as possible and eliminated it from the storage and handed this I/O or IOPS headroom back to the environment that you can now use for additional workloads. So that might mean something like a busy SQL server that normally can only run as fast as the storage will allow it to, is now able to get more work done in the same amount of time, quite simply because it's not waiting on the storage so much before being able to get on with its next operation or transaction. But this additional IOPS headroom may also mean that you can now add more instances of SQL, more workloads, more users, more machines over that same storage infrastructure than you otherwise would be able to do. And what you haven't needed to do is rip and replace the SAN, which is an expensive proposition. You haven't had to upgrade the SAN. You've taken that storage hardware that you've already bought, you've already paid for it, and are now actually getting all of the compute you've paid for. So I hope that answers that. So I started to sound like a sales rep then. Apologies for that. I am just a lowly engineer after all. So Steve Strong says, how is the software licensed? Per ESXi host, per host CPU socket, or per VM? Good question. Okay, so I am going to put my sales hat on for this bit so I can answer this properly. You can license it per instance, so you can have one license for one virtual machine or physical machine or physical server. In a virtualized environment, you can license a host hypervisor, so that's your ESXi box or your Hyper-V server, and that means you can now install the Vlocity software onto as many virtual machines as you want to host in that physical server at no additional cost. To give you a rough idea of pricing, a single server instance is about £350. Don't kill me if I haven't got that exactly right, but it's around that sort of mark. The sales reps will be able to give you proper quotations. That's worst case list pricing. Of course, we have quantity discounts, we have educational discounts, government discounts, and so on. So definitely reach out to your Condusiv rep if you want to get proper pricing. But that gives you a rough worst case idea. £350 per server. If you wanted to license a host hypervisor, the cost for that is somewhere around £2,500. So basically, where you have more than about 7 VMs on a host, it's actually going to start working out cheaper to buy a host license than it is to sort of license each VM individually. If it's a single physical server, that's a single Vlocity license, 350 quid or less, depending on how many you buy and what how much you can twist the arm of the sales rep. Similarly, if you're running the software in the cloud as well, if you're using infrastructure as a service and you've basically got Windows VMs running on something like Azure or AWS or some other cloud provider, again, same licensing principles apply, but because you don't have access to the physical host hypervisor, you would buy it on a per VM basis. So I hope that answers that. So Jonathan Jackman says, is there a version that can be installed on the hypervisor rather than the guest machines? In terms of Hyper-V, yes, there is. In terms of VMware, not yet. We do have on our roadmap, I wasn't going to talk about the future roadmap today, but as long as you guys promise not to tell anybody else, I'll let you know. So on our roadmap, we do have a version where it will have tiered caching. So you'd still have the RAM caching in the VMs as you have today, if that's what you wanted to use, but you would also have a second layer of cache down at the host hypervisor layer, whether it's an ESXi box or a Hyper-V host or something else. And you could choose whether to use both layers of caching or just one or the other. So that is coming. However, that being said, for best results, I would recommend that you put the software into those Windows virtual machines. And the reason for that is that is the layer where the write I/O traffic gets split. That's where we can prevent those split IOs from occurring in the first place. If you try and prevent that split IO traffic down at the hypervisor layer, well, you can't. It's too late. The traffic's already been split the layer above. So by putting the software into the VMs, that's typically where you're going to see the best results. I hope that makes sense, Jonathan. So Adrian, he says, thank you, you're very welcome. So Andrej Philip, forgive me if I've not pronounced that correctly, I probably haven't. He says SQL must be capped pre-deployment having at least 8 gig. Oh, I see you're referring to this up here. So you don't really have to cap it pre-deployment. The amount of memory that that our software uses dynamically adjusts depending on how much RAM is free at any given time. So if you wanted to install the software and then cap SQL, well, after a few minutes, we would see the additional memory being available, and we'll be able to start using it. It says at least 8 gig there. That's having at least 8 gig assigned to a SQL Server, to the actual machine itself. What you want to do, regardless of how much RAM is assigned to the machine, leave at least 4 gig of it free, not being used, available physical memory. And you can check that quite easily on a SQL machine. If you click the Windows Start button and type in msinfo32. That'll bring up the System Information Report. And then close to the bottom of that first page that comes up, it'll show you how much physical memory is assigned to that machine and how much of that is available physical memory or free memory that's not being used. And that'll work on both physical machines and virtual machines as well. So yeah, try and leave at least 4 gig free. Okay, so let's see. Oh, that's a question here I can't quite see in its entirety. Let me see if I can make a bit more room here. Okay. So Steve says, do you recommend VMware Paravirtual SCSI controllers with the increased QDepth registry values in addition to the Vlocity software? Certainly it's not going to hurt by any means, but the two would be quite complementary to each other. Because we're sitting way above that in the storage stack, you would get the benefit from the Paravirtual SCSI controllers and the benefit before that from having Vlocity sitting on the top. I hope that makes sense. Sahid Arif says, need a product like this to assess and improve SQL applications. Well, if you've got application servers that are interfacing with those SQL servers, actually our technology applies there as well. That's the Vlocity software if you want to reduce the I/O traffic and introduce the RAM caching, and also that I/O assessment tool that I mentioned. You can use that on the application servers as well. It's not just limited to SQL. I know this presentation has been geared very much towards SQL servers, but it could be any type of Windows server. Right, as I understand it, it prepares space on storage to put large extents. Okay, yes, it does. At the NTFS layer, so those NTFS volumes, your C drive, D drive, E drive, what have you, that's where it will quietly in the background help you have that large area of, or large areas of free space to make it easier for the Windows Write driver to write into without having to split the data up. And it will give the Windows Write driver the intelligence to actually use those large areas of free space. So you're right, it does prepare the space on the storage at that NTFS layer. It won't do anything in the storage at the back end. It won't interfere with the way the storage controller works for the SAN or anything like that. We're only operating right at the very top of the stack at the Windows layer. So does this reduce storage capacity? No, it doesn't. It's not designed to decompress data or deduplicate or anything like that. So the storage capacity that you have in your storage isn't going to change. And as it gets filled up, it'll get filled up. If you're close to that storage capacity and your disks are full, we can't prevent the situation where you're going to have to get more storage space. But where we can help is when you're doing your next tech refresh and you're speccing out your next SAN, for example, that you want to have for the next 3 to 5 years. Well, maybe because we're reducing the I/O traffic that's going down to the storage, maybe you don't need to buy quite so much of it. Maybe you don't need to spend so much on your next SAN to over-provision and overcompensate for all of this excess unnecessary storage traffic that really doesn't need to happen on a second-to-second basis. So hopefully that makes sense. Is the software supported by SAP? I don't know if, well, they wouldn't support our software directly. If you wanted support with our software, you would come to us. I guess what you're trying to say is, do people use it in an SAP environment? The answer to that is yes. And if you have a look through some of those case studies on our website at condusiv.com, you'll see some examples of that. We've been able to improve the performance there. But SAP must be running in a Windows environment. It isn't going to work in a Linux environment, I'm afraid. So for 8 gig memory capped, was it for allocation of memory caching? Okay, so let me try and be clear about this. The slide is, to my mind, a little bit misleading. Forget about the 8 gig for a moment. A machine should have, a SQL Server should have at least 8 gig provisioned to the machine, not to our software, but to the machine. Typically, SQL Servers these days would have more than that. They might have 16 gig assigned to a SQL Server, or 32 gig, or if it's very busy, 64 gig or even more. For our software to start caching, I would recommend that you make sure that there is at least 4 gigabytes of memory that isn't being used by SQL or the Windows operating system or by anything else. That's 4 gig of unused available physical memory. That would give us roughly a 2 gig cache size. As I mentioned before, that's usually enough to eliminate somewhere between 30 and 50% of all of the reads from having to go out to the storage. If you need additional performance from that SQL Server, well, allow it more memory free, give it a larger cache size, and it'll be able to offload more of that storage I/O traffic from that back-end SAN storage. So I hope that makes sense. Right. Andres says, you said 4 gig free RAM is good to have. Yes, that's right. Yeah, if you get 4 gig of free memory, you're in that's a pretty good starting point to show what the software can do. Then he says, what there isn't so much. No, 4 gig is not a huge amount of RAM these days, and that, as I say, that would give us roughly a 2 gig cache size. But we can do a lot with that 2 gig of cache. That telemetry algorithm is very, very clever at figuring out what needs to be in the cache and when. And you'd be surprised just how much of that read traffic can be offloaded away from the storage, even with such a small amount of cache size. But as I say, if you need more performance, give it a larger cache, give it more free RAM to play with, and you'll offload a greater percentage of that read traffic. Right. So we want to move nav SQL Server on a physical machine, no VMs, no SAN. What is the use of your application in this case? Okay, so if you've got a SQL Server with direct attached storage, which is the way everybody used to do it before virtualization came in, and there are still a lot of people doing that now, that direct attached storage will still have a maximum amount of IOs per second that it can cope with. It's going to have an IO ceiling beyond which you can't really go, and at which point IOs will have to start getting queued up and wait in a queue until it's their turn to be processed. So absolutely, it has a play there as well by reducing the amount of IO traffic and handing IO headroom back to the environment. And even if you're using a PCIe flash card, or you've only got SSDs as your direct attached storage, well, quite simply, RAM is faster. So the more of those reads you can satisfy from the RAM, it's going to help the performance. Okay. So somebody else was saying, is it supported by SAP? So we've covered that. Okay, Zahid says, unfortunately, the server only has 4 gig of RAM and hosts our ERP system, and we do not want to spend all the money updating the server, as then we might as well update the ERP system. Fair enough. If you are RAM constrained, the software will still help by reducing the write IO traffic, making the transfer of that traffic more efficient. But you're not, quite simply, you're not going to get the most out of the RAM caching, I'm afraid. There's not a lot I can do about that. If you are RAM constrained and you don't have the option to add more RAM, I'm afraid our hands are tied. It's not going to set the world alight there. So Kevin says, hi Spencer, is this presentation recorded, as I'd like to review the entire presentation from the start? Well, you're a sucker for punishment. Yes, it is being recorded. The link to that should be going out to everybody tomorrow. But as I say, you're very welcome to reach out to me directly as well if you have any questions. And that's for all of you, not just Kevin. Okay. So Jonathan Jackman says, does it matter if the storage is direct attached, iSCSI, fiber channel, etc.? I guess the short answer to that is no, it doesn't matter. Because we're sitting so high up in the storage stack. Basically, as long as the storage at the back end is compatible with Windows running above it, it is going to be compatible with our software, because it's still Windows creating the storage IO traffic and sending it on down to that back-end storage. So it doesn't matter if it's direct attached, iSCSI, fiber channel attached. It doesn't matter if it's SAS drives, SATA drives, SSDs, whatever. As long as it's compatible with Windows, it will work with our software. Okay, so I have 90 databases running in a single SQL Server, and for the memory caching, would it know when to stop caching when a large amount of data is already in cache? So yes, I mean, those algorithms are pretty good at figuring out what needs to be in the cache and when, and also when to flush the cache. It's very reactive in this version. I guess, again, probably the best thing I can say to you is try it. You'll get hold of a copy, try it and see just how much benefit it can give you with, because everybody's environment's different. You could have 2 identical SQL servers running on 2 identical pieces of hardware, but you're going to be running different workloads in all of them. So the best thing to do is to try it with your real world workload, with your actual hardware, and just see what difference it can make for you. Okay, so how long would the cache memory be available? Is everything removed after the server restart or cluster transfer? So the RAM cache obviously is in volatile cache memory, so it would be removed if you rebooted. If you were to do a vMotion from one ESXi host to another, for example, it would maintain the cache if it's keeping the machine up. But if you take the machine offline, the cache would be recreated. But that, it only takes a few minutes after you've brought the machine back online for that cache to start becoming active again. So, Jürgen de Beauvoir says, where can we find the IO assessment tool? I don't find this on the Condusiv download page. Oh, you should be able to. Let me see what's the best way of me being able to make this available to everybody. I'll tell you what, I put my email address in the chat box earlier. Make a copy of that now and email me directly, and whoever requests it, I will get the IO assessment tool out today. And I'll get a download link sorted out for you so you can get hold of it. All right. So Steve Strong says, is it only Windows OS supported? Yes, I'm afraid it is. We don't have a version for Linux or anything other than Windows at this time. But if you have some Linux machines and some Windows machines and they're all sharing the same storage, well, if you're reducing the amount of workload coming out from that Windows part of the estate and reducing I/O queue depths, reducing average storage latency, and basically handing I/O headroom back to the environment, those Linux machines will be able to take advantage of that by default without having to have the software installed on them. So as long as you're running some Windows, we can help. If you're running all Linux, we can't help you at this time, but there is a Linux version on the roadmap, but I don't know when that's likely to be released to the public, I'm afraid. Okay, good, that's helpful. Somebody has very kindly put the IO assessment tool download link in the Q&A box. Let's put that in the chat box as well for everybody. Okay, good. All right. Crumbs, we have a lot of questions, a few more to get through here. Okay. Well, I do appreciate you guys staying with me for this. I hope well, for me, these questions are very intelligent, very worthwhile. I hope they are. Hope the answers are equally as good. So Pierre Linger says, would this software also work for Oracle machines, or is it specifically developed for SQL? No, it absolutely does work for Oracle machines. In fact, if I flip back to one of these previous slides, I think there's an example of that in the case studies. Here we go, Suncoke Energy. I think they're an oil and gas company. 53% reduction in I/O traffic for greater throughput on Oracle workloads. It absolutely does benefit Oracle as well. So what are the built-in functions? Well, you have really very little to configure in terms of built-in functions. It's designed to be a set-it-and-forget-it type software. You can, of course, turn the different features on and off, so you can enable or disable the caching. You can enable or disable the write aggregation and so on. So yeah, it's very easy and straightforward. Okay, so I think that's pretty much it for the questions, and forgive me, I'm going to have to wrap this up because I know that there's another webinar going to be starting very shortly in North America. So you guys have my email address now. If there are any questions I haven't been able to get to, please accept my apologies and do feel free to send me an email and I will answer each of those personally. Thank you very much for listening and for your patience and for staying on this amount of time. And I'll look forward to hearing from you guys in the future. Take care and thank you.